constant. What must actually remain constant? Not actually, also. Yes. Back, leg. Go to your notes. Yeah.
Resistance.
Say again?
Resistance.
Yes, the resistance must remain constant. That is important that you know that. Okay, right. So they say they must be directly proportional to one another. Which one represents directly proportional, Kananelo? Yes, D, if it is a straight line. Okay, just have to check here. Is it just to naughty? Ne?
Wow. Really?
What's wrong?
Vaccine. Must be sick because it's very
Vaccine.
I think she's not feeling well, I don't know.
Yeah, I must take her out because she's strong woman. Maybe she's sick, she come to school. So this one really COVID.
She's going to fix the coat.
No. I say COVID.
Okay, right. Next question. It says, in this circuit below, the battery has neglectable internal resistance. So what is neglectable? Shh. Yes, you can ignore it. Now, you'll see a lot of these questions, they'll say, neglectable internal resistance. That is because next year's chapter, we're going to look at internal resistance. And a lot of schools do that already this year. Okay, we didn't do it, but a lot of schools does. So that is why they say, just ignore it. We're not looking at grade 12 work just now. The resistance of an ammeter and wires may also be ignored. Okay, now when you look at this circuit, it looks quite scary. Okay, it just looks like a circle and you think maybe it's difficult, maybe it's not. So what I'll advise you is to redraw the circuit and to start with, just ignore the voltmeters. Okay, so we see that this is the positive side, this is the negative side. So we go from the positive side and then we get somewhere where the current must split up. Okay, so we get to a point where the current must split up. And there where the current splits up, the first branch is just through a 4 ohm resistor and then it goes back home. So this one is just through a 4 ohm resistor. Then the second branch we see goes through an 8 ohm and an 8 ohm resistor and then back home. So this one goes through an 8 and an 8. And then goes back home. So that's basically the circuit that we have there. Okay, and now the one on our right hand side looks a lot easier. Okay, I'm going to zoom in on the one on my right hand side. If I take my highlighter here, I see that the current splits up there and there.
No,
He did give back highlighters, but I'm still needing 3 highlighters. Okay, right. So our volts is only going to the parallel combination. We know the volts in parallel are the same. The volts in parallel are the same. So if, for instance, we have 10 volts, then we know 10 volts goes there and 10 volts goes there. Okay, the volts in parallel are the same. But in the second parallel branch, there's 2 equal resistors, 2 identical resistors. So it means this 10 volts, this 10 energies, 10 sandwiches must split up so that we have 5 that goes there and 5 that goes there. Okay, so I'm going to explain it in another way. Let's say you come here, you have a choice. You either take Math Lit or you take Math. If you take Math Lit, you get 10 sandwiches. If you take Math, you get 10 sandwiches. But if you take Math, you have 2 periods of Math. Okay. How many sandwiches do you have for each period? 5. Because for both together you get 10, but you have 5. You all understand it? Okay, right. Now they give names to that. They say this is V1, this is V3, this is V2. And they ask, the reading on voltmeter 3 will be equal to what? Okay, now we can say we know that voltmeter 1 must be equal to voltmeter 2 plus voltmeter 3. Like this is 10 and this is 5, 5. So 10 is equal to 5 plus 5, right? Is this one of the options that they give us? No. Okay, if I rearrange it again, voltmeter 3 is equal to, then we'll get V1 minus V2. Is that one of the options they give us? No. Okay, and we can see that option C and D is we can't get it. From there, we can't go to either C or D. So they are out. Okay, now they say we must compare it to voltmeter 1. Is voltmeter 3, that's 5, equals to voltmeter 1, that is 10? No, it is half of it. So that is why the answer is B. Who got it right? Well done. You.
Did you copy? Yes.
Okay, right. Can you see for multiple choice? I didn't do which one looked good and then I take it. I drew a circuit. I highlighted. I did a few calculations. Okay. So, my tip to you is when you get to this exam, try this method. Let's see how it works. Don't start with your multiple choice. Your first question will be vectors. Then you do the long question on vectors and then you do the multiple choice on vectors. Then you do the long question on Newton, then you do the multiple choice on Newton. So that your head gets working, you get into the mode of Newton's, because multiple choice is always deeper thinking. It's never just guessing. So then you get used to it and then you go to that multiple choice question and you answer. Okay. Please let me know if you tried that. Write it somewhere in your question paper. Say, ma'am, I tried your method. And I'll see if it works or not. Speaking about your exam, I will hand out a piece of paper next week what you must study. It's going to be one question paper, 150 marks, 3 hours of the entire year's content. It will not have gases in it. So not Boyle's Law, that's the easiest chapter, but anyway. And I'm not setting the question paper, the department is bringing it. And then we must... This chapter will be in it as well as the next chapter. Next chapter, so let's move. One paper of 3 hours. Yeah. But what I'm going to hand out to you next, what they send us is chapter for chapter, how many marks for each chapter. I'm sorry, I wanted you to write 2 question papers, but it's not in my hands. Huh? No, I can't split. Okay, right. So, let's go to this one. We're busy with work, energy, power. Says, consider the circuit in the sketch. Then they ask you, calculate the energy transferred. And we said energy transferred is the work, it's the joules. That's what they ask. In the 6 ohm resistor in 2 minutes, and then we said 2 minutes, we don't like it, we want to convert it to seconds, so we have to multiply by 60. Then, if we looked at the work formulas, there we saw that we need either the volts or the current for us to be able to do a calculation, and then we went and we calculated the volts going to the 6 ohm resistor. I just want to go to your picture. Oopsie, sorry. So we saw here that we have 36 volts altogether. We want to know how much of the volts goes there. So what we did is we said 6 plus 12 gives you 18. Then we said 12 divided by 18. We did a ratio times 36. And that is how we got to, what did we get? To 24. 24 volts. Okay, right. But why did I write 12?
You said 6.
Why did I looked at the wrong resistor? I'm sorry. We don't want to know what's the volts going there. We want the volts that's going to the 6 ohm resistor. I apologize. So we said 6 over 18 times 36. That gives you 12 volts. Okay. Right. So that's how we got there. Now we must calculate the work. Piso, you did answer. Tiamo. What formula do we have that we want that we can calculate the work? Are you paying attention? Tiamo, are you with me? And we have resistance, time, and volts. It's on the previous page. Literally the previous page. Huh? Read it to me. Let me hear. Shh. Yes? Hello. Kom, maak vannacht. Yes, go. Yes. Shh. We don't have current. Thelma, do you see we don't have current? Where is it T?
On top.
You must enunciate. All right, 12 squared, 120 over 6. And if you calculate that, Chichi, what do you get? Joules. Good. Katlego. If I ask you how many kilojoules is that, what would you tell me? Kilojoules. You walk to school 2,880 meters. How many kilometers do you walk? It's the same thing. Joules to kilojoules, meters to kilometers, milliliters to liters. Same thing. You divide by 1,000. 2,88 kilojoules. Right. Then they ask, calculate the power of the 12 ohm resistor. What do you mean? What is the symbol for power? Okay, Whitney. Say again. Well done. Sorry, P, power, and it's measured in watts. Okay, and they ask for the 12 ohm resistor. Now, if you look at the formulas, you will either need the work or the volts or the current. Okay, which one do you have, Tapelo? Volts, work, current. Do we have the work? Okay, be careful. We calculated the work for the 6 ohm resistor, and they're asking for the 12 ohm resistor. So it's two different things. So you cannot use that. We don't have that. Come. Yes, Miles. Yes. If we look here, this volts was 36. We knew that 12 volts went in there, so this is 24 volts. So that is 24 volts. So we don't need current. So we need a formula with resistance, volts, and power. And that formula is V squared over R, I think. We're at power now, P, power. Okay, so that is 24 squared divided by 12. And what do you get, moles? Huh? I didn't answer something incorrectly, but go for it, Tapelo. Say again. 48. For reals. And the unit? What does W stand for? Okay, right. Now the next one is a good multiple choice question. Okay, this question I elongated a bit, I made it a bit more difficult, but the concept is very important. Okay, very, very important, especially for grade 12. So this is important that you do practice that. Okay, it says there, 3 identical light bulbs are connected in a circuit as shown. Explain what happens to the brightness of A and B when C burns out. Now, Lepelo, when they speak about brightness, what are they basically asking? On the previous page, I said brightness is linked to power.
Yes, ma'am.
And what? Okay, so they are basically asking you, compare the power of A and B. Okay, now they say when C burns out. So it means we must do calculations before C burns out and after C burns out. Okay, those are the two things, and then we must compare. Okay, so in a multiple choice question, they'll just say just before. So like compare the two's brightness just before, but here they ask what happens to A and B when C burns out. So you must compare before and after. Okay, if we look at the circuit here, take my highlighters, then I see the total current passes through A. The total current passes through A. And then the current splits up to B and C. Now there's a mistake there. That line should not be there. Right, and then it goes back. And then if I look at the volts, at the energy, the 6 joules, it needs to split up into 2. It needs to go to the series resistor and the parallel resistors. And we know the volts in parallel are equal to one another. You must understand what you highlight, ne? Alright. They also said, I don't know if I emphasize this enough, is 3 identical light bulbs. So that's why I made them 2, 2, and 2. Okay, but if in a test I just say they're 3 identical and I don't give you values, you can make them 1, 1, 1, 5, 5, 5, 10, 10, 10, whatever you want to make them. Okay, now we must calculate the power before and after. So what we're going to do is we are going to use this formula. P equals V times, no, it's not V, sorry, it's I squared times R. I think that's the formula. Is that a formula like that? Okay. Ne? Is it fine? Okay, and we're going to do that for A, and we're going to do that for B. Because we do not have the current for them. So we must first go calculate the current. And if I want to calculate the current, I must first get the resistance. Okay, so because they are in parallel with one another, I'm first going to go calculate the total parallel resistance, then add it to that one so that I can get the total circuit resistance, and then I can calculate the total current. Okay, so a lot of calculations. So 1 over R parallel is 1 over 2 plus 1 over 2. That gives you 2 over 2. So if I swap them around, it's again 2 over 2. So R parallel is 1 ohm. Make sure you know where I get the values from. Ask if you're unsure. Look at the picture. Okay, so that is R parallel. I want the total resistance will then be 1 plus 2. That gives me 3 ohms. Okay, so I'm going to just go to my picture. So this together is 1 ohm. And then you add it to that one to get 3 ohms. So the total circuit's resistance is 3 ohms. Now I want the total current. Total current is the total volts over total resistance. The total volts, what was it? 6. 6 divided by 3, that gives you 2 amperes. Okay, so if we look at the current through A, there's A. We said the total current passes through there. So the 2 amperes passes through there. So that gives you 2 squared. And if we look at A's value is 2. It's 2 ohms. So times 2. And that gives you 8 watts. Then if we look at B, there is B. Can you see that from there, I'm going to zoom in there. Here we have 2 amperes going in there. Then how much amperes goes through B? 1. Because they are equal to one another, they are the same, they are identical, the current splits up equally. So the current through B is 1 squared, the resistance is 2, and that gives you 2 watts. Alright, so that is before C burns out. We can see that A will burn much brighter than B. Now what happens after C has burned out? Now when C burns out, this happens. What type of circuit do we have now? We have a series circuit. So it means the total resistance we are just going to add together. Now the total resistance becomes 4. Right? So here we see the total resistance will not be 3 anymore, it will be 4. What will happen to the total current? Increase or decrease? Say again? Say again? Decrease. Because resistance is inversely proportional to the current. So if the resistance becomes more, the current becomes less. Okay, well, let's just write that down. So the total current now, total resistance is now 2 plus 2, which is 4 ohms. Because now it's just in series with one another, so you don't have to do that big calculation. Now the current will be 6 divided by 4, that is 1.5 amperes. Okay, so I just want to say something. So can you see when the resistance increased, the total current decreased? Yes, Katlego. For this one. Okay, so this one here, oopsie, sorry. Here, this is gone now. So now we just have a series circuit like that. There. Just 2 plus 2. Just that plus that. Okay, right, now we want to get the brightness of A and B. So the brightness of A, the brightness of B. Again, I'm going to use the same formula. Can you see now that the current is the same everywhere? Okay, the current doesn't split up. So if the total current is 1.5 amperes, then A will get 1.5 amperes and B will get 1.5 amperes. I'm going to zoom in there now. They are the same. Their resistance are the same. 1.5 plus 1 times 1.5 gives you what? 1.25. Yeah. Yes. 1.5 plus 1.5 is 3. 2.25 times 2 gives you 4.5. 4.5. Times 2. Okay. So A was, first it was 8 and now it's 4.5. What happened to the brightness, Sepang, of A? It was 8 and now it's 4.5. What happened to the brightness? Say again? Yes, it decreased. And Panele, what happened to the brightness of B? It increased. So you're going to say the brightness of A increased and the brightness of B. Brightness of A decreased, sorry, and B increased. Okay, now this, like I said, was a long calculation. In an exam, just finish writing. Ryk julle ook kos? Ja. Jo, lekker. Ja.
What KFC?
Ek kry samosas. That is just in my...
It's spicy.
Maybe I just want some. Anyway, right. So, in an exam, they will not ask both. In an exam, they'll ask one. They'll say, all right, just compare the brightness of A and B. Then you'll say A will burn brighter than B. Or just compare afterwards. What is the brightness of A and B? Or they will bright with the same brightness. Or they'll burn with the same brightness. Okay. Right. Then the last bit there is the cost of electricity. Now, who of you has, not PHSC electricity, what do you call it? Koopkrag. Yeah, who buys electricity? The units for their house. Yeah, you pay ESCOM monthly. Yeah, okay. Okay, right. So, well, let me just see who buys electricity units in their house. Units. Okay, right. So, the rest of you that do not buy units, do you buy ESCOM every month?
Yes.
I don't wanna know. Right? Do you know how I feel about bribing? Nee, I've given you the speech last year. Nee, ons gaan nou nie daaroor nie. Nee. We're all Christians, nee? Alright, anyway. So, but you all know about units. Okay, so, you know at the beginning of the month, you must buy your unit for the month because at the end it becomes more and more and more expensive. Nee? You all know you should actually buy on your app, your banking app, you should buy your units. It's much cheaper on there than going to the shop. Yes?
Is 12 watts.
Okay, wacht. Ik ga er niet beklei oor dit. Right. Okay, so this is what we are looking at here. So we are looking at what is the cost of electricity in a house. How do you calculate the cost of electricity? Now it says there, a unit for electricity in South Africa is kilowatt an hour. That is 1 unit. So if you go by units, you actually buy kilowatt an hour. Okay, so what is that? It's 1,000 watts for 1 hour. Okay. And then if you must calculate the cost, you're going to just say, okay, what is the cost of 1 unit times that unit? Okay, now let's look at how does that work. It says there, a household uses the following electrical appliances 24 hours in 1 day, 6 light bulbs of 100 watts each, blah, 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 blah. Just let's quickly look at the fridge. The fridge is 600 watt fridge for 16 hours, but a day is 24 hours. How does that work? Do you put off your fridge? No, no one does that. So how come your fridge is only on for 16 hours? Have you ever heard, during the day it's noisy at home, but at night you suddenly... Okay, so what your fridge does is it regulates itself. So it goes, say you put it on, it must be at 10 degrees Celsius, then it works to make it cold until 10, and then it switches off. And then it goes, and then when it reaches, say, let's say it reaches 12 degrees Celsius, and it switches on to make it cool again. Okay, so it switches itself on and off to save electricity. So that is why you shouldn't leave your fridge door open, because then you lose electricity. Your fridge will not work for 16 hours, but for 20 hours. Okay, that is why where it seals, it must seal nicely, otherwise you pay more. Okay, sharp. Right, life lesson there. Now they ask, calculate the cost of the electricity if a unit costs R2.50. How much does a unit cost? I don't even know. We pay ESCOM, the real amount.
How much is the real amount?
Too much.
And which one is better than Roshidi?
Units. If we can, we want units. No, we actually want to do off the grid. We want solar, we want gas. I don't want to owe ESCOM anything. Alright, anyway, so we have there for the light bulbs, I'm just going to abbreviate a bit. Light bulbs, we have 6 times, now they say there 100 watts, but our units are in kilowatt. How do we go from watts to kilowatts? You divide by 1,000 or times 10 to the power -3, so that's 0.1. And that is for 4 hours. Then our dishwasher is 1,500 watts. How many kilowatts is that? 1.5 kilowatts for 1.5 hours. Then we have a fridge. The fridge is 600 watts. How many kilowatts is that? 0.6 kilowatts for 16 hours. Then we have the geyser. It's 2.5 kilowatt for 5 hours. And you have your TV. That is 0.75 kilowatt for 3 hours. Your computer, your Wi-Fi. Huh? And all of a sudden you don't want to live anymore. This afternoon you're going to say switch off, switch off, switch off. Huh? Okay, right. We are with the question. Banela, you do the first one, then Cananelo, then Tipiso, then Tiamo, and then Chichi. Calculate. You get 2.4 kilowatt an hour. Okay, I'm not going to write that for everyone. Cananelo? Say again? 3. 1.5 times 1.5. Yeah. Tipiso? 9.6. 9.6. Can't be.
Mine is 2.25.
Okay.
2.25, yeah? Is 0.6 times?
It's 9.6.
Rara. But 6 times 6 is... Never mind. Sorry. 9.6. Tiamo? Nee man. 2.5 plus 2.5 is 5.
7.5.
Nee, times 5, ne? Not times 3. 5, 12.5. Alright, and Chichi? 2.25. Okay, now we must add them all together, Katlego. Yes, add them together. The sum of. Say again? 29 units for a day. 29 units.
So how much is it rent?
That is what we're going to calculate now. And if 1 unit is R2.50 and there's 29 units, how much will it cost you?
Every day.
R72.50 per day. Too much.
Cheap.
And some of us don't have dishwashers or fridges or pizzas.
You don't have a fridge?
Yes.
Yeah, you.
We said since luxury. We dig a hole and put everything there.
Rara. Okay, right. So this afternoon, actually, I want you to go look at how much kilowatts does things take in your house. Like the kettle. See, so now next time you go buy a kettle, do you want to buy the fast one or do you want to buy the slower one? No, slow. but it uses more kilowatts than the slower one. Your water will boil. You will wait 5 minutes or 3 minutes. Never mind, we're not going to go into that. Right, so let's start with this work. We'll see how far we get. If we don't finish, it will be homework because we must do one more chapter. Okay, right. So there they give you a circuit. It says a circuit allows you to determine the resistance of a resistor X. The 12 volt battery. Now remember, anything below the picture is not in the picture. So they say 12 volt battery with an electrical internal resistance. When switch S is closed, the reading on the ammeter is 0.5 amperes. So that one there reads 0.5 amperes. Okay, now I take my highlighter. There my little man walks. I see that ammeter measures the total current. The whole current passes through the 8 ohm. The whole current passes through X. And then it gets back home. So we have a series circuit. Then if I look at my volts, my 12 sandwiches, my 12 energy, I see it has to split up into two. It has to split up into the 8 ohm and X. Say again? Yeah, but they say when the switch is closed. Okay. Now there are state Ohm's law in words, Botomelo. Hey, shh. When, if provided, yes, when the temperature is constant. Hello, Tiamo, she doesn't have to thank you to you. And did she ask you for help?
Just indirectly.
No, she didn't ask. Right, then calculate the resistance of resistor X. Now you can see it counts 5 marks. 5 marks tells you it's either a small calculation and a bit bigger one, or 2 medium calculations, or 3 small calculations. Just it means you have to work. Okay, right. So they'll ask calculate the resistance of resistor X. Okay, now if we look at X, I just know that the total current passes through there, and that is 0.5. But I don't know how much volts goes there, because I can't say 12 volts goes there, because 12 volts must split up into 2. But what I do have is the total volts and the total current. Then I can calculate the total resistance. And then, because they're in series with one another, I can just subtract that, and then I know what is the resistance of X. So 2 calculations. Okay, I'm going to do it on the right-hand side. You do it in your book. Are you going to do it there? Will you have space? Because the questions at the bottom is 5 marks, 5 marks. Alright, so right there on your info table, you write total resistance, total volts, total current. Okay, so you have total volts, total current, total resistance. The total volts we know is 12. The total current is 0.5, and we do not know what is the total resistance. But we do know that the total resistance is 8 plus X actually. Why can we just add them together? Because they are in series with one another. Okay, so if I go to Ohm's law, R is V over I. We know R is 8 plus X. The volts is 12. The current is 0.5. So you have 8 plus X is equal to 24. Dividing by half is the same as multiplying by 2. Or if you have 12 cakes and you must divide them in half, how many halves will you have? 24 cakes. Where's your math teacher in primary school? Huh? You never worked in cakes? See, I only work in food. Only in food. Alright, so x is equal to what? 16. Alright. Not too difficult. 5 marks for that. Now, next question there. They say, study the circuit below. The battery has an EMF of 12 volts with neglectable internal resistance. Tapelo, what is EMF? It's not in your notes. It was last year. I forgot to put it in again. There. EMF. You can either tell me what does it stand for or what is the definition.
When did we do it?
Last year.
Electronic.
Yeah. Yeah? Electromotoric force. Electromotoric force. Write it down. Electromotoric force. And what it means is, it means that is the maximum volts in a battery when no current passes through it. Let's not speak about what's new to your brain, eh? Aye, guys. My poor children one day. Yeah. Where did we do circuits last year? Did we do electrostatics? We did. Stroombanen. I don't get it. I remember stuff. Hier zo. Hey, wie lag so lelijk? Okay, anyway. Right. No, you got 11. Alright, so now we're going to highlight. We see that the current passes through there. Then the current splits up. What's wrong? Yeah. Splits up there and there. Okay? So it's like you choose, either you are into the business side of things or you're more into the scientific side of things. Okay? If you choose business, then you do accounting and business studies. If you choose science, then you have a choice. Do you take physical sciences or life sciences? Okay, do you see? So here, you must do both. And here you have a choice. So if you choose the science side, do you choose physics or do you choose life sciences? Okay, right. Obviously, this is not real life. It's in the life sciences and accounting. Tiamo, do you really want to know? I did the best in accounting. Because Tiamo, if you do really well in something, then it's difficult for you to explain. If you just get it, it's difficult to explain to someone if they don't get it. You're like, but it's easy, get it. But if you struggled with something and you had to figure it out on your own, then you can explain to someone, you know where they struggled, you know where the problem is. No. All right. Okay. Are you all right, Vals? Say?
Is she fine?
She's just agreeing. Non-verbally. Right, Donkey, let's pay attention. So, if you choose the science side, then you have two choices what you want to take. Okay, right, so there's inception. There's parallel inside a parallel. Then if we look at, we continue, then we see that ammeter there does not measure the total current. It only measures the current in one of the parallel combinations. This ammeter only measures the current through that parallel combination. Okay? It doesn't measure the total current. Then if we look at the volts, the energy, we know the energy in parallel is the same. So for the big branch, these two big branches, they are the same. So it will be 12 volts and 12 volts. Right? And if we look at the inception, the parallel inside the parallel, we know that their volts must be the same. Okay, now, I highlight this and this looks difficult, but it's not as difficult as it can be yet. Okay, right. So your homework is to finish this question and the next page, because I only see you next week, Wednesday and Friday, and then we're done.